Hey everybody, this is Larry. This is me doing week 5 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this poem. I have not done this before, as you can see, so I'm always excited for those. So 487, max consecutive ones. 2. Alright, given a binary array nums, we know the maximum number of consecutive ones in the array if you can flip at most 1 0. Okay. Yeah, I mean, oh, excuse me, jeez. I think we've. Mm, Follow up could be interesting, but without the follow up, the idea is going to be. I mean, there are two ways to think about it. One is sliding window. That's the way that I was initially going to think about it without the follow up, right? Because you can just kind of yeah, sliding window, left, right, and then just kind of push and pop. But the follow up is actually interesting. If you cannot store all the numbers in memory, then what can you do, right? Well, the idea is just the same, but or similar to sliding window. And I just thought about this, so you're watching this live, I suppose, which is just to store the last zeros that you see, and then basically, yeah, because then now whenever you see the next zero, you won't pop up to the next zero, right? So you just have to store the last two zeros, and I think that should be good. Because you can assume everything else is ones, right? So let's try that. I think I think the not the problem, but that part may be a little bit trickier just because it's easier to make mistakes. That's all. Yeah, we can also start. I mean, this is just a coding thing. Probably could we can just add more if statements, but I'm just gonna add something like this so that we have sentinel values. Technically, this makes a linear space, but I don't know, whatever. But yeah, for I okay, for x and num, so then I'll just do the index explicitly so that we kind of, so basically for now, I'm pretending that the input's a stream and that we don't store more than well, we can't store more than over one constant time, or sorry, constant space. So yeah, so basically I00, right? So here we increment I at the end. But now we have I and X, right? What do we do? So if X is equal to 0, we do something. If X is equal to 1, we do something, right? So if X is equal to 1, then we look at the last two zeros, right? So we can do something like this. It's for zeros. Terrible naming maybe. But just Z append I, right? And then if length of Z is greater than 2, then what? Then Z dot pop left, but it's not a queue, so I don't know. Let's just rewrite it as a queue then, just because I'm lazy, even though it's a 2-item queue, right? And then now, if you have a 1, it becomes interesting, right? So then now you have two. You have so the first. So what we doing with Z, right? So the first 0 is the 0 before the 1, the first 1, and then second 0 is the one we are flipping. I think that's basically the idea behind the Z. So then that means that Z of 0 plus 1 is going to be the index of the first I, and then I is the current index. So then now inclusive is going to be I minus this plus 1, which I know that they can't throw out, but I like to write it this way so that, you know, it's a little bit clear, so that it's inclusive of the ones, and then best is equal to, oops, something like this, and that should be good. I mean, obviously with that best. Yeah, let's give it a spin on a submit. Oh, oh, okay. Yeah, I guess that is the case because hmm, eh, missed an edge case. Because basically this just never or in a zero we never check. I guess we could have done it. I guess we didn't need to do it this way. Um, yeah. Oops. I mean, I kind of made this case just because I was thinking about it, but I didn't really, to be honest, I just didn't consider this case. If I consider this case, it actually generalizes very obviously because it's just treating this as that and all this stuff. Yeah, let's give it a submit. Hopefully I don't have another edge case. I do have another edge case. Oh, man, I am really bad at edge cases today. That's what I get for trying to be lazy. But why am I returning two? So, oh, because now this Sentinel Zero does something. Because initially when I created this Sentinel Zero, I did not expect it to run here. So okay, fine. Because then now it was using that as the Sentinel Zero. Because the first zero we never use because we just count as a delimiter, but the second zero we actually do. So that was a silly mistake. Okay, a lot of silly mistakes, mostly from me trying to overgeneralize, but also the other thing is, just to be honest, I was going too fast and I didn't really think about edge cases. I probably could have just like, spent 5 minutes thinking about edge cases. I would come up with them, but I don't know. What is this, right? So this is constant space. If you don't count this, ignore it. Yeah, this is constant space. I guess I didn't need to do it this way. I guess I could have just put Q as you go to. I mean, we could have done this as well. Then now I can actually say that we're constant space. Maybe. Oh no, this is a zero, so this is index is negative. No, this is zero. So then now we start at one, and then there we go. Okay. So then now we can actually say that we're constant space and linear time due to this. Remember that this only has 2 items, so this will always be all of, just 2, which is all of 1. Yeah. That's all I have for this one. Let me know what you think. Let me know how you did. Yeah, stay good, stay healthy to good mental health. I'm in Naha, in Okinawa, in Japan. I'll see you later and take care. Bye bye.